In my continuing efforts to never actually finish this project, during testing I found that a couple of the I2C sensors would simply just stop reporting, so that they'd just silently fail. And rather than spend ages trying to solve that particular problem, because it'd like take a couple of days to appear, the fault to appear. So rather than try and fix that, I thought it'd be more interesting to try to add in a power restart system. So what I've got, this side here is like the test setup, so I don't have to keep messing about with that. So what the Teensy's doing here is the test setup is a yellow button is like a power restart system. Press that, flashes the green LED and then restarts. The blue button is a Watchdog Timer built into the processor for the Teensy. So I press that, 2 seconds later it'll restart. I'll explain the Watchdog stuff in a bit. On the actual circuit itself is a 555 timer and a relay. We've got a 5 volt power supply which converts the incoming in this case 7 volts, that converts it to 5 volts, and the 5 volts is then onto the charger here, the charger module, which is a TP4056. The idea is that this relay cuts the 7 volt power that's coming in, and the little delay is there to power down properly and cleanly. You know, sometimes you flick a circuit on and off, the power hasn't quite cleared properly, like because of capacitance and things. And the circuit doesn't restart cleanly, so the idea is that it stays off 5 seconds to allow everything to stop properly, and then it just clicks back on. So the circuit, so I'll power in 7 to 9 volts probably. That goes through the relay, which is connected up down here. I wasn't entirely sure how to do that without making it look messy, but anyway. Through that 5 volt power supply module, which is this here, and then that gives us the 5 volt rail. The 5 volt rail is actually part of this circuit here, so the whole of this lot is driven at 5 volts, and then where I need to, it's cut down to 3.3 volts, which I'll talk about in a moment. So the 555 timer circuit came from the book Practical Electronics for Inventors. Sorry. So that's kind of like that section mostly is from that book. The circuitry for switching, because I've got 2 methods, I've used transistors. These SS8050s, they're just ordinary NPN signal transistors. So the 3.3 volts is generated on the microcontroller board. So on here, down here, like I said. The idea of how this works, I do believe, is that for this is normally low. So when an event has been triggered, it goes high. That switches on this transistor, and then that pulls, I'm going to call it pressure, pulls the voltage down here, and that goes low, and that causes the timer to trigger. This one is normally high, so when an event is triggered, it goes low. So it's the opposite of the power restarter eventually. So that gives a path to ground, takes pressure off here, and then that causes the circuitry to trigger. And then so the relay switches, that opens, it restarts. And the lithium battery charger module, VBAT, is there to keep the timer powered. The timer and the relay, that keeps those 2 powered for the duration of the thing. There's probably better ways of doing this. I think you can actually just do a very simple capacitor and transistor type circuit, but I want to do it like this. The 555s are TLC 555 CPs. These are CMOS variants of the 555. That's to lower operating voltage. These will work from, I think, 3 volts, whereas the normal timers start at 5 volts. And again, this relay is an EC23NJ, popular in telecoms type equipment. It's a 3 volt relay, so again it'll trigger happily from the battery. Batteries, when it's fully charged, about 4 volts and drops right down to wherever it needs to go, but it's not being used enough to ever need for me to ever worry about that. So I just need to now translate this into strip board using the medium of soldering. Now I've got all this wired up, I can press the button, 2 seconds later it goes off, comes back on, starts up again, starts blinking away. So slightly different battery, but essentially the same. There's a little change on the circuit diagram, basically a schoolboy error, so let's just get that out again. Up round here, I had, this was going up to the 3.3 volts through a 10k there, and then there was this diode. It didn't work because when you're switching it off, 10k isn't being pulled up, or the 10k is no longer being overridden, so it'd switch off and then switch on. It just go into a switch off, a loop of just switching on and off. So the relay just click 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 click, because the input, the trigger, wasn't being pulled up by the 3.3 volts because that wasn't on yet. So moving the 10k and that onto the VBAT was fixed that problem. It was like that on the test system, but I just didn't mark it up properly. Yeah, before I start talking about the programming, I'll just cover what this is here. This is an INA219 current sensor. It's measuring the input voltage and the amount of total current being taken, and that's been sent through to the Teensy over an IC² connection. I'm not going to cover any more details, but you'll see it in the program. Programming. All this is going to be on a GitHub somewhere. I'll put in a link in the description. Visual Studio Code, as usual for me. Easy bit first. So this is the yellow button. Press it and it does it. The yellow button case is the trigger button here, so we've got our pin set up here, and then we go down to setup, pin mode, yellow button output, input pull down. That's the green LED that flashes on and off, and 2 timer is the connection to the timer circuit. Yellow button trigger in the main loop. Looking out for the button to be pressed, so if it's high then it knows it's being pressed. There's a little function here to wait until finger is away from the button, so let's go to that, and you can see here it just does while the state is high, so it keeps on reading the button, so when the state goes low it just exits out of the function into the loop again, and then it goes through the sending restart output to the serial port. Ready LED is just a flashy LED, so go to that definition. It just flashes it on and off rapidly, in this case 120 milliseconds, and then switches it off and goes low loop, and then it sends the output high. So remember on the circuit it'll be triggering that that transistor. Pulling the trigger on the timer low, and that sets it off. So in this code here, these 3 lines, it should never get beyond these 3 lines for this. It's, you know, the whole thing's been switched off. So that's the simplest way of doing it. The purpose of this one is primarily to allow me to do things like a scheduled restart. So I could use the date and time functions to trigger it to restart at, let's say, 2 o'clock every morning or something like that. And I can also use it so that I can detect if the state of something is persistently failing or not recording. I can look at it to make sure that a range of readings, if they're remaining the same, then possibly the sensor has failed. So I'll just have it then go, oh, that's happening. I'm not entirely sure how to write that code at the moment, but that's on my list of things. It's time to look at the Watchdog Timer. For me, my experience with Watchdog Timers is rather limited, and this is the first time I've used them in this kind of project, so I'll be missing out a lot of functionality. So call this like a beginner's guide or something like that. I'm so new to this kind of thing, I've even made some notes. So yeah, so Watchdog Timers are basically a way of checking to see if the microcontroller is still alive, that the software's not crashed the controller, not gotten stuck in an infinite loop, or being messed about with, because sometimes you know, you write your code and it just goes wrong. So that the Watchdog Timer doesn't become active and start resetting your board, you need to feed it every so often. I'll go into detail with that when I'm going through the software. And you can also be used to, there's a thing called window mode, which can also be used to see if a sensor is providing data too quickly, but I've not used that in this project. What it won't do is detect when a sensor is giving false readings. So if a sensor is just giving you a garbage response or a 0 response, then it won't trigger, because you're still getting the standard response. It's just wrong. If it's just giving you wrong data, if a sensor is giving you wrong data at the right time, then it won't trigger a Watchdog. The Watchdog Timer for this, I'll link in the thing. The Watchdog Timer for this, the library is one made by Tonton81 on GitHub. This library is only for the Teensy 4 and 4.1 development boards, as they are using the i.MX RT1060 processor based on an ARM Cortex-M7 design. This is for the Arduino environment. Each microcontroller manufacturer has the way of calling Watchdog Timers, so you'll need to select a library appropriate for your use. I don't think there's a common library that covers all of them. So in the software, up at the top, there are 4 different Watchdogs. Watchdog 1 and 2, WDT1 and WDT2, are kind of like the most basic ones. They're both reasonably similar, and they both have 2 options for outputting to an external trigger. So I'm in this setup the timer circuit to trigger the relay. Watchdog 1, when triggered, the chosen out pin constantly gets set low. Once that goes low, it stays low until the board is reset, and the board gets a software reset if you've got no external hardware to perform that task. Watchdog 2 is very similar, but the timer just sends a pulse to the output. Oh yeah, and the processor is not reset, so you either have to use a built-in reset function, but it will still trigger an external device if you need to. The external Watchdog Timer, EWM, as far as I can tell, the EWM is supposed to be used in conjunction with Watchdog 1 or 2. It sits outside the main processor and not supposed to only trigger if the internal watchdog that you're using fails. So if the microcontroller has a complete brain fart and completely stops working to the point where the internal watchdog timers can't trigger, then this one triggers. So it doesn't run callback function that I'll talk about in a moment, whereas the other 2 do run that callback function. The external Watchdog manager can trigger an external pin to have an external reset device like I've got here. There's also Watchdog 3, which uses clock cycles rather than time. I tried this one, but I couldn't get it to work. Probably just doing it wrong or something like that. And all of these Watchdog times need to be fed within a timeout period. So in my setup here, let's go through the software on the system. So I'm using Watchdog One. Kind of like spent ages experimenting with different timers. So I've now defined it in the usual kind of way. And I'll go to setup, and we've got our config callback here. So I've got a function called Watchdog callback. The Watchdog gets triggered and it goes off to this function. So it should be a short function, collects data, writes it to an SD card, outputs it to a serial port, whatever you can do with it, and then have it do a soft reset, or you can use it to trigger your external device. Now timeout and trigger got me a bit confused at first. So from what I can tell, the timeout is the total time for the restart, and the trigger is the amount of time the callback function is run for. So with a timeout of 6 seconds like I've got here and a trigger of 4 seconds, the Watchdog needs to be fed every 2 seconds to prevent a timeout. On a timeout event, the callback function will run up to 4 seconds before a soft reset is triggered, or your external device. So a soft reset and the external device are basically triggered at the same time with Watchdog One. I can show you that here. So if you go to our bottom bit, make that a little bit. So you can see here on the screen it's feeding the Watchdog, and that's been done once every 1.5 seconds. And the number you see is the number of milliseconds since the board was switched on. So I'll press my blue button and you can see restarting 1, 2, Watchdog callback called, trigger 3, 4. For some reason it's going up to 4. Now it's just doing the restart function and away it goes. I know, back to life. So yeah, on the output pin, the config Watchdog pin on mine, I've set it to pin 20. So the next bit, now we've got to our main loop. You can see down here in now the little blink without delay type loop, Watchdog feed. So delay millis is set to 1500, so 1.5 seconds. So it's feeding the Watchdog. There we go, it's there. And we toggle the LED on and off, the main green LED. Back further up, here's our blue button, detect. So if it's high, button's being pressed, wait till fingers away from the button. So that's an infinite loop. The Watchdog is now not being fed. After a couple of seconds, it now goes to the callback function. It's up here. So Watchdog callback. Ignore this. That was like me trying something, I've forgotten to take it out. What I'm doing here is kind of like you do your data collection at this stage to try and debug what it is that's actually caused the error. So you then need to write that out to an SD card or send it down to a serial port to something that's kind of like can record the data properly, because obviously with the board resetting it starts from fresh when it resets. So here again I'm just using another infinite loop, the trigger countdown, and that's it. And then once the trigger has completed, then that's it. The board then gets reset, the pin goes low, and the soft reset starts. And that code here is what you'd use. A Watchdog reset is what you use in the cases where you're not actually using that kind of functionality that I am here. So that's a soft reset. But in this case, that code never runs because there's an infinite loop in the way. I think kind of that's it. Thanks for watching.